Okay, so we are 6.1 day 2. We are going to be applying our exponential function. So we need to remember that an exponential function, we need to know the base of it, right? So we have y equals a b to the x minus h plus k, right?
Yep.
We are not going to do a whole lot with h and k today unless they give one to you. You're not going to be writing those. So you'll be worried about a and your base. Remember your base is your ratio, right?
Mm-hmm.
And then just your x. So we're going to kind of fumble through this and see what happens because I haven't given you anything, right?
No.
So we just got to figure out how to do this. So it says the population of a large city was about 4.6 million in 2010, and the growth rate of 1.3% for the next 4 years. What is the exponential function that models the population of the city over 4 years? So B is my rate, correct?
Yes.
Yeah, so it's
1.3.
okay, but 1.3 is what's just happening from this year to next, and that would
Oh.
only give you the amount. What if I want what I have and the amount? What do I have to do to those two things?
Multiply.
Not times,
Add.
add,
Oh, yeah.
okay? Because what I have now is 100%, correct?
Yeah.
Which would be 1,
Yep.
yes? So I would have to take 1 plus 0.013,
Yes.
correct?
Yes.
Because I need the 4.6 million I already have, don't I?
Yes.
That would be the 1. And then I need to add 1.3% of that. So if I take those two together, I can get that accomplished. But, so that's my B, yes?
Yes.
What's my A?
4.6.
4.6, that's my initial amount, isn't it?
Yes.
Okay, and I don't know why I wrote it so far. And we already used P. Why are we using P? What are we talking about?
Population.
Population, and we're doing 4 years, yes? So we probably need to take this to the fourth? Because we're going to do that 4 times, right?
Yeah.
We're taking it times itself 4 times. So I can't do that. Well, I can do this part. What is 1 plus 0.013?
1.13013.
So I have 1.013. And this is a growth function, yes?
Yeah.
Okay. If it was a decay function, would I add 1 plus my rate?
You could subtract.
I would subtract it, wouldn't I? Okay, and the 1 is there because it's 100% of when I started. Okay. So I can't do that without a calculator, and you shouldn't be able to do that without a calculator. So
Are you
you
sure?
will write this on your paper, and then you will do what?
Calculate it.
Use a calculator. Okay, so when I do that, I think I get nothing on my screen here. Times, and please put it in all at one time in your calculator. Remember the exponent is that caret button, right? So I have approximately 4.8 what? 4.8 what? What's my million what?
People.
People. I probably need to say I have a million of what thing, right? Oops, with 2 E's at the end of it. Okay, so I have 4.8 million people. Does that seem reasonable?
Yeah.
Yeah.
Yeah, I have 1%,
what's-
like a little over 1% a year. I'm going from 4.6 to 4.8. That's
Yeah.
reasonable, right? We did it wrong before. We just put 1.3 in before. And if I just put 1.3, that'd be 130%, wouldn't it?
Yeah.
Yeah, so you gotta make sure you make your decimals, percents, decimals, things like that.
Now you got to do it by 40.
So now it says that the population continues to grow at the same rate. What will the population be in 2040? So now I don't want P of 4, I want P of what?
30.
P of 30. How'd you get 30?
That's how many years?
2040 minus 2010.
Because 2010 was my initial year, right?
Yeah.
Okay. So that's 4.6 times 1.013 to the 30th. Does anyone have their calculator out?
Yes.
6.8
6.8 what?
million.
People.
People. Sorry. What city is this?
Los Angeles.
Not
No.
Wymore.
Los Angeles.
I believe
Oh,
it's gonna be one more in 2 years. Two years.
Okay, if we could grow at 1.3%, everybody would be happy, right? You wouldn't even have to start with 1.6. Where are they getting their people from?
Yes.
Where they get it from?
Other
There's
cities.
other towns.
Other towns,
Oh.
right?
That's
What has
I
happened? What's happened to Wymore's population over the last 30 years?
Went down.
It's gone down. Okay, and where are those people moved?
Anywhere else.
New Beatrice.
Some Beatrice,
Anywhere else.
Lincoln.
They're
Lincoln.
even better places than
Okay,
here.
so
Odell.
our metropolitan places are getting
Chicago.
huge, right? And our rural places are getting
All the
smaller, and so we just have to deal with that population growth. Not me, I'm not gonna go big anymore. I want to came back.
They basically
They all
move anywhere
moved to
that's
Blue
better
Springs.
than
That's what.
Oh, really? For 30
They all
Where
moved
you
to
go
Blue Springs.
What?
Where do you go big?
Blue
I
Springs
lived
is
in
awesome.
Lincoln and Tucson,
Ah,
and everywhere else has been small.
ah.
Okay, so a factory purchased a 3D printer in 2010. The value of the printer is modeled by the function f of x equals 30 times 0.93 to the x, where x is the number of years since 2010. Okay, before we answer any questions, is this a growth
Yes.
or a decay?
Decay.
decay because the base is smaller than 1.
Look, not my base, my rate.
Funk rate.
That's my rate, like that, my B.
Okay.
Okay, my B has 1 and the rate, correct? So what was the rate? If I had 1, I started with 1, right?
So minus 0.07.
0.07
Yeah.
gave me the 0.93, didn't it?
Yes.
So it's decreasing in value by 7% a year.
Okay.
Does that seem feasible?
Yeah.
Yeah. Most things that we buy as people or companies, they depreciate, means the value goes down, correct? Okay, so there's the formula we use. Okay, so what is the value of the printer after 10 years? So I'm going to use what for my variable?
10.
My FP, what do you want to use?
Oh, printer.
Printer?
Well, you want value, right?
How about
So
value, right?
V. So V.
B?
Printer.
Okay.
Right.
Right, printer. Writing P is dangerous because writing P, you can use, it's usually population or principal or
Printer.
Why would you put?
or printer. What?
Why would you print?
It'd be 10.
Because
wouldn't
it's V of what?
it? 10.
What variable we have?
Oh,
Wouldn't it be 10?
Well, yes, but if I wrote the equation, would it be V? Would it be V of T?
yeah.
Okay, and this would be T. I would never write an equation like this with an X, ever. Because what is changing this amount? Time, right?
Yeah.
So if it's changing over time, should I put time?
Yes.
Yes. Okay. You could call it F if you wanted to, but I would never use X as my variable. Okay, so V of 10
10.
Yes.
is 30 times 0.93 to the what?
To the 10.
10.
10.
I have the answer.
Tell us
It
the
would
answer.
be 14.52.
$14.52.
Dollars.
Yes.
Yes.
Hey,
Boom,
so this printer, after 10 years, is only worth $14.52. What was it worth when I bought it?
That's what we have to figure out now.
No, it's in the equation.
A 3D printer for $14.
$30.
$30.
That's
Yes.
Okay.
I'm
Oh, yeah, it would be 30.
Now they probably should have maybe added in hundreds of dollars, right? Probably $300 would be more reasonable.
Probably.
But it's okay. It doesn't matter.
How
If
good
you
is
were
the
to
3D
get-
printer?
3D printer for $30.
It probably wouldn't be a very good one.
No.
It probably would be depreciating at like 20% a year.
Yeah.
3D push
So even if it's hundreds of dollars, it's still losing quite a bit, isn't it?
Yes.
Okay.
Compared to the 14.
So does the printer lose more money, more value, excuse me, in the first 10 years or in the second 10 years?
For the second 10 years, because you have to do 20. What? And,
Well, what's the shape of this? What's it look like?
It's first because it's a big decay. It's,
It goes like this, right?
Yes.
Okay. So is it
Okay,
gonna
so it is
lose
more
more
than that
value
half.
here or here?
The bottom
The
should-
bottom.
The second one.
I probably shouldn't.
they'll use it a lot quicker.
It's gonna be like- I don't know. Let's see.
I'd say the second
How
one.
do you wanna do that?
V of
V10
20.
and then V20. Or I guess we just need V10.
We would just need V20, wouldn't it?
Or V20, yeah, that's what
Yeah,
I meant.
V20.
20?
Yeah.
Evans is smarter man.
Yeah.
Evan is, you're not wrong.
The 20.
Could I have done V of 10
Jesus. I have the
and
answer.
start with this?
Well, you see,
Yeah.
yeah, but I feel like that'd just be more complicated.
After 20 years,
Okay,
You
what
get-
did I do with the second one?
you
You
plug
just-
your
you're just
rate,
gonna
you
combine
plug your
them.
price.
I plugged my new
New
value,
price.
right?
Yeah.
Okay.
Could be worth
And
Both
now-
should both of these give me approximately the same
Yes.
thing?
Yes, now you have
Okay.
$7.03.
So this is $7.03?
Yeah.
What about the second one?
Oh,
$7.
So we have lost more in the first 10 years.
Do it. Somebody do it. Second one.
oh, by the way, you're 30 and the 20% depreciation year, I dropped it down to 60 or $6.
Yeah.
I don't know how to put it.
No, we're
in.
dropping down to $7.
How much? Did you give an answer yet?
No, she said a $30 printer. Or the
Yeah, a
depreciation
$30
of
printer is
20%.
gonna depreciate much quicker than a $300 printer, correct?
Yep.
Yes.
Yeah.
6, then we'll go quick.
What is the problem? I need this stuff out.
Get someone do it.
Isaiah's trying to.
I'm trying to.
What me? Is this 14.52 times point?
I was.
Go.
Now he's talking, gosh.
He's getting confused.
7.03.
Wow, they're the same?
They're approximately the same. They're not exactly. But
Oh,
did
yeah.
either of those ways, get the same thing? About the same?
Yes.
Yes, okay. But this one I'd have to like, I don't know. So the first 10 years, how much did I lose?
16 something dollar. Or,
How about
well, is that the.
15?
15.48.
I was doing it a different way. I didn't
Okay.
put it all on.
So
Quick math.
here I lost 1548, yes?
Yeah.
Yes.
Okay, and here, when I do it this way, can I just take this amount and this amount? I don't have to go from one to the other. It doesn't really, if I did this one, I'd have to subtract from here, yes?
Mhm.
Either way, what do I get?
662.
662. So
Quick math.
How do you know that?
Because I'm smart.
he subtracted. He took this minus this. Okay, so where did I lose? The first 10 years or the second 10
First
years?
10 years.
First 10 years.
Wait.
Okay.
Well, after a third 10 years, you'd be at $3.40.
Getting a new printer.
No, I did
Okay.
good printer.
So that's usually, if you think about what an exponential graph looks like, my change in my slope is a much more rapid change at the beginning than the end. Because where this bottom part, it almost like you're thinking from here, like just the actual amount, but when we do rate of change, that's a slope, isn't it? These are just not constant slopes.
Okay.
Okay, so now that we've done that, how about I give you the actual equation? Nice to me. You've done this already. But now I'm going to tell you a growth model looks like A of t, amount after time, equals A times 1 plus r to the t. Remember, A can't be 0. That makes sense. B has to be greater than 1. And B, because the whole thing is B. This whole thing is B, correct?
Correct.
So B is 1 plus R because it's growth. And I just went through that. A is initial amount, R is the rate of increase or decrease, T is time, and A of T is the amount after time. So decay, we don't add, we do what?
Subtract.
Subtract. Same equation. Did we just do those two things without having, yes. That 1 is 100% of your initial amount. That is your initial amount. That's where the 1 comes from, okay? It stands for 100% of your initial amount.
Yes.
So we just use this equation to find out what,
You would, if you had to write an equation, this is what you would use.
but if you're just like, just to find like the range of, let's say if you had a 5% depreciation value. You
Yes.
just plug in 0.05. and
For the R. Yes,
And then you just go.
yes.
Okay, well, let's see.
Now, Fifth Hour wanted to know why they weren't doing ACT prep because they're all juniors. And I will tell you that ACT is Algebra 1, Geometry, and Algebra 2 for the most part. There's very little. Everyone says, there's trig on it. No, the only trig on it is stuff that you should have gotten in geometry, okay? They are doing more ACT prep by continuing to learn in class. than stopping and actually try to teach them problems they have no clue how to do. Does that make sense?
Yes.
So, and I would guarantee you there is going to be one of these problems when they take it next Tuesday.
Just say no.
Garrett, I'm a junior in here, right? There are gonna be one of these
No,
problems.
there's,
There is no junior.
Garrett's a
in it.
sophomore.
You're a sophomore, I was thinking
That's
you're a
my
junior.
brother.
Garrett's
Alex, your brother. But,
I was
so,
like,
when you guys take the ACT, you guys could take it this year though. Not Tuesday, but you could take it. When you take it, I guarantee you, there's going to be one of these problems on there. I don't know in what form they're gonna ask it, but there is gonna be a growth or decay problem.
Good.
Okay, so everyone got it?
No.
Give me
I'm writing stuff.
Yeah. Evan's writing all this stuff down.
I am right.
Notice that B is 1 plus the ratio, right? Or 1 minus the ratio, and we noticed that on the last one. Callie, did you have a question? Are you sure? Okay.
She has a question. She's just too afraid to ask.
no, I'm not.
Kelly asks a question.
Yeah.
Okay, is everyone good?
Evan's not
T
down
and A.
I am never waiting for Evan. Okay.
You should wait for me. I gotta catch up.
Okay, determine whether each function represents.
What?
No.
She said,
No, I did not.
Maybe.
I did not finish.
She said bucket.
Okay, each function represents growth or decay. Write the base in terms of a growth or decay, like inequality. Identify R and interpret the rate of growth or decay. There's a lot of words there, and you have like 3 problems. Just do them how we do this. Got it?
Yes.
Okay, so is this a growth or decay on A?
Decay.
It's decay because B, this whole B is less than 1, yes?
Yes.
Because I took, how did it get there?
I don't know, man.
What was it before?
1
It was 1 minus
0.96, right?
Just 6.
just 6
Oh,
If there's 9, 6 would be
because
another
it's
0.
0.4.
oh, never mind.
Wait.
Yeah.
Yeah.
1 minus x gave you 0.4. How would you figure that out?
Then you would add, subtract the 1.
Subtract the 1 and you would get 0.6.
Yes. You would. Guys, 0.6.
No, you
plus
wouldn't.
0.4
Yes, you would.
equals-
Okay, well, you were looking at them if they were dumb, so I
No.
just said the
Okay,
opposite.
yeah.
Okay,
Yeah.
so this is how they want you to break this down back to what it was. Got it?
Yes.
So it's a decay problem. Yes?
Yes.
And what is my rate?
Well, whatever your B, 0.6.
0.4.
0.
No.
0.6.
0.6 is my rate, or 60%. The 0.4, guys, is what you have left after you take your decrease.
Yeah. Yeah.
Make sense?
Yes.
This right here is after you have done that. See that? You're going backwards. Okay, growth or decay here.
Growth.
Growth. Because it's bigger than
1.
1.
Oh, what?
So it's growth.
That's 1 plus 2.
So it was 25 times 1 plus what?
2.
2. I don't even know what this is.
That's an H.
Yeah, I was wondering what that was.
That's an H.
So what is R?
2.
2. So what percent is 2?
200%.
200%.
That's a big percent.
I don't even know where that H came from.
It wanted it to be there.
H plus K.
Magically, it's
The H's.
Okay, growth or decay here.
growth, because it's more than 1. If you work it out. Right?
Decay.
It's not.
But it's -3.
I was gonna say decay
Oh,
is a
Well, I don't know if
negative.
that makes a difference.
But it's negative, so let's write it out what it would look like, right?
Yes.
Okay, so this would be -3 times, now this is obviously 1 plus something, yes?
It's
Yeah.
So it's 1 plus, well 1 is 5, yes, 5 or 5 is 1. So 13 minus 5 is
8.
8.
And
Okay.
it's gonna be a growth.
So we're gonna keep going. R is what?
5 over 8.
8 over 5,
Yeah,
Over
that-
5.
which is 5 goes into 8.
160%.
Shh. 5 goes into 8
1 time.
one time. Goes into 30 how many times?
6 times.
6 times. I want to take it a step because some people can't do it that quick. So 1.6 is what percent? 160%. But we have this issue. What's our issue?
The negative.
We don't know.
The A.
This negative. Because this negative should take this graph from this to what?
To that.
To that. Okay?
So it's a decay.
But a decay looks like what?
That.
Uh-oh.
It's both.
Reflect it. Distribute a negative, can't you? Can you distribute
Let's
a
put it in our
negative?
calculators and see what it looks like.
Okay.
So in your graph calculator, because we just kind of guessed what it looks like, right?
No, we know.
So y equals, right? Everyone should be doing this.
Give me a second.
Mine's at home.
Well, you should always have it at school.
Yes.
As Austin passed around his bag looking for the calculator
That he doesn't have. Okay, so how do I graph? I put y equals, yes?
Yes.
Y equals.
Okay, y equals what?
Oh, that's weird. That's not right.
-3.
Oh, I know where the h is from.
What? Ah.
It's from the c.
How?
Yep.
It should
Well-
be h of x. Okay,
The
so
one you
negative,
do-
so I have to use the negative button, yes? Right here?
Negative.
So negative,
Where's
negative button's right here.
-3.
Negative 3, parenthesis,
13 over 5.
13 divided by 5, and your parenthesis, caret,
Carrot.
x.
X.
Where?
And an enter.
And I'm gonna hit
No.
zoom, probably 6, because I've messed up my graph sometime.
Six.
So this has to be a decay, doesn't it?
Yes.
Yes.
Does it go
But
down?
it's not though,
Okay.
'cause it-
But it goes down, right?
Yes.
It decays. So, but is it decaying to 0?
No.
It's decaying to negative.
It's decaying to negative and positive value.
Huh?
So it keeps
But
going.
is it a decay?
No.
Yes.
Wait, mine won't do that.
Because it go down.
It
Uh,
doesn't work.
Okay.
No
Wait, how do you
solution.
get the X? I got
There's an XT theta n button right next to alpha.
This one. No solution.
I think it's no solution.
Okay, I have a hard time
I
because
said
when
that.
it's decay, okay, if I think decay, I'm thinking of
Down.
the value of something, yes?
Go down.
Mhm.
Population,
Money.
a chemical, yes?
Yes.
Yes.
Can I go less than 0 on any of those things?
No.
No, I can't go less than 0, can I?
No.
Well, if you
Does this even start above 0?
No.
No. So this doesn't even start above 0.
So it's not real.
So
Look, if you flip it upside down, it works.
if you flip it upside down, it works.
It's fake.
So it's decay.
It's
It's
okay.
fake.
Eat-
Okay.
Take that.
No solution.
So I don't know. If you hit decay, if you put decay, I wouldn't say no. I wouldn't say
What
you're
if we
wrong.
put increase?
Okay. Does this graph go down?
Yeah.
Yes. So is it technically decaying?
Yes.
Okay. Did it decay because of my R?
No.
No.
Take to the negative.
What?
Your
Because of the negative.
amount.
Okay.
Yes.
Did you figure it out?
She had a minus instead of a negative.
broken.
Throw it
Because
at
you
the
keep
wall.
hitting stuff.
Throw it at the wall.
You have it paused.
How dare you?
Thinner. You have to give it time to think.
I don't want it to think.
No, throw it at the wall.
Do it.
Burn it with fire.
I fixed it.
Okay, no, you didn't fix it.
Miss Vic.
Okay, so we need to use our calculators for the tool they are. I would have a debate with someone about whether this was a growth or decay. I would definitely not say it's a growth.
It's an increase. So.
Okay,
No solution.
but can you decay past 0 is the other question.
No.
So it's a philosophical question in mathematics.
incorporate velocity.
Okay, so a car was purchased for $24,000 from a factory, and the equation is not a factory. The function is y equals 24 times 0.8 to the x can be used to model the value of the car in thousands of dollars x years after it is purchased. So 24 came from what?
Price of the car.
The price for the car. Do you see what they did? Instead of putting 24,000, they just said in thousands of dollars, right?
Yeah.
So the person at the end knows to multiply by what?
1,000.
Much neater, correct?
Yes.
Okay, so they do that a lot with population. You saw they just did 4.6 and then just a million. Yeah, I would rather do that than a lot of zeros. How about you?
Yeah. Yeah.
No.
Okay, what rate? Oh wait, what rate of growth or decay? Is it a growth or decay?
It is A to K.
How do you know?
20%.
Point eight.
It's
The-
This is less than
One.
1. So it was 1 minus what?
1 minus
One minus
0.2.
2. Okay, so decay
Yeah.
Yeah.
at what rate?
20%.
20%.
Okay, does that sound reasonable for a car to
Yes.
decay 20%?
Yes.
Cars do not hold value
I
usually.
thought it was like you lose 15% off the.
Like when you drive it off the lot.
Yeah.
Some people have said half your value is lost the day you drive off the lot, but it It also
You don't drive it
depends
off
what
the
car
lot.
you buy.
Oh,
You drive it
Geico.
out of
No,
the
they
inside
got
of the car.
the.
Okay,
I don't even. Yeah.
So-
50%.
so it means that every year I'm decaying by 20%. But we've talked about this. The first part is going to be a lot, right?
Yeah.
But after I've already lost 20%, is my next 20% going to be less?
Yes.
Yes, because I'm starting off with less. Okay, so graph the function on a reasonable domain. What do the y-intercepts and the asymptotes represent? And when will the value of the car be about 5,000? Now, mathematically yet, you do not have the tools to solve that unless they happen to get the same base, and I'll show you. So it's going to be where I do some trial and error, right? Okay, we also could graph it and check it out too,
No.
right?
Oh. What?
What's the graph?
Okay, so, what's my domain? Because it's all real numbers,
Yes.
But it has to be greater.
but our
than
numbers are
0.
years, yes?
Yes. It has to be greater than.
So 0 to negative.
So 0 to positive infinity, yes?
Yes.
Okay, so we're only gonna start, this is 0, right? So my domain is gonna be x such that x is greater than equal to 0? Because I can start at 0 time, right?
Yeah.
Okay,
So,
what's my range gonna be?
Well. Y.
down
So
to the
five, so
Y.
no.
Is it gonna be greater than,
Greater
or
or equal to
what?
20.
Is it gonna be greater than or less than?
Less
Greater
than
than.
24, or
No,
less
less than.
greater than 0.
Less.
It's gonna go down.
It's gonna go down, yeah?
Yeah.
It's gonna be less than.
It's gonna go down?
Less than 24,000.
Okay.
Right?
So when so range, well, it's gonna be less than, we know that. And I'm gonna put less than, and we're gonna have to decide, because it may not be 24,000. It's gonna be around 24,000, right?
Well, that, if you bought the car for 24,000, you'll lose value. Is it gonna be less than 24,000 then?
Hmm?
If you bought the car for 24,000, that means your value is gonna be less than 24,000.
Right, but could it be equal to 24,000?
Yes.
Yes, when?
Well, when you first buy it.
When you first buy it. Okay, that's what I wanted. I wanted a reason why.
Oh, okay.
Wouldn't it be
Okay.
less than or equal to?
I thought you were
Yes.
saying it wasn't
No,
24,000.
I said I wanted someone to develop an actual reason, not just because it's 24.
Yeah, my
Okay, so
The FP.
this thing's gonna start at 24,000. Yes?
bad.
And then what's gonna happen to it?
Gonna go down.
Go down?
Well, we gotta calculate what the price after 1 year is.
Okay.
The value of the car after 1 year is.
Could I just figure out when it's worth 0?
Yeah.
So that's in 24 years.
So if I set this equal to 0, so it'd be 24.8 to the x equals 0, right? I divide by 24
Yep.
and get 0.8 to the x equals 0. Now, I don't have the skills to do that. Do you guys have the skills to do that?
No.
Yeah.
No?
Yeah.
Okay, we don't have the skills to do that yet. And so, well, the calculator can't, I can't throw, cause X is in the domain right now, isn't it?
Yeah.
Yeah, and I can't plug things in a calculator like that, can I?
No.
No, so I don't have the ability right now in any form at your level to do that.
I can ask Google.
Okay, so I know it's gonna look like this, correct? Do I know it's gonna look like that?
Yeah.
Okay, so that's what it's gonna look like. But I said, this doesn't exist over here, right?
No.
Okay, so that's what it looks like. What does the y-intercept represent?
The
Value of
starting
the car.
price.
So the initial price?
Yeah,
Okay.
initial
What does the horizontal asymptote represent?
0.
0 when it's jump, right?
Yep.
And technically, it's never gonna be worth 0.
Yeah.
Cause I could still sell it for scrap. Yes?
This would be so car
But it's probably not gonna be very much.
What if you burn it?
Still can sell, the metal won't burn.
Mr. Beast can sell it for
You
$0.
want to bet? I'll burn the metal.
Okay,
I'll melt the car.
so how do we figure out when it's worth $5,000?
Putting 5,000.
Putting values for what?
X.
For X. So you guys got a calculator, try some values. When do you think it's gonna be worth $5,000?
30 years.
Cause I'll show you mathematically how we would do it. Okay, this would be mathematically how we would do this, correct?
Yes.
And we would divide by what?
24.
24, so we divide by 24. Actually, this would only be 5. Why would it be 5, not 5,000?
Because we're speaking in thousands of dollars.
We're speaking in thousands of dollars.
So it would be
So at 5 over 24 equals 0.8 to the x. Well, we know if we could get these bases to be the same, we could set them equal to each other, but I don't know how to get 5 24s to base 8 either.
Point 21.
I don't even wanna mess with it, okay? So we don't have the tools yet, so we're gonna do plug and play, plug and guess and check, whatever you wanna call it. Okay, so what do you guys wanna try? X equals what?
4.
X equals 4? Okay, what do you get when X equals 4? Well, you got calculators, use it.
Approximately 4 years.
What do you get when you plug in 4?
When you plug in 4.
I'll plug in 4.
9.8.
9.8.
Nine
So
point nine.
$9,800, right?
Well, carbon.
So,
800.
830.
300.
oh, whatever. It's not 5, right?
No.
Okay. Then
16
what do you want
years.
to try? 16 years?
7.
I want 16.
24.
You're gonna be
Okay,
way.
what do we, after 16 years, you should know 16 is not even
0.675.
close. 0.675, so it's worth $675.
But
That's
actually,
Let's
awesome.
the
go
Clark.
smaller to like 2.
What?
What year?
Can we go smaller?
What year did you say?
It would be high.
What do we want to be worth 5,000?
Yellow.
We want to figure out when this would be approximately $5,000.
But
Or 5.
but the number got smaller with the bigger.
Right, because the more years, the less my car's worth.
So we need to go back.
We need to go back.
It's not 10.
So it's not 9,000. So
I know
we
you know
do
the
like-
answer, put your hand down.
I'm gonna speak on behalf because someone else figured it out.
It's not 10.
Okay, you can speak on behalf of somebody.
I told him to yell it and he won't yell it.
It's 7.
It's 7.
Yeah.
Okay, at 7 years, it's like $5,030 or something.
Not right.
Oh,
No,
it's not
it's
right.
actually it is 5.033.
Yeah, so $5,033.
Yeah.
Okay,
Can't
so
right.
is at 7 years, it's approximately worth $5,000, correct?
6 years.
Okay.
10 months.
So now let's put this in our calculator, and I'm going to show you how exactly to do it. Okay, so y equals, what equation are we putting in?
That one.
That one, 24 parenthesis 0.8 caret to the x. And every variable they use is x, because it's xt theta n. Okay, does everyone got it in there?
Yep.
Okay, and hit zoom 6. Oh, actually, I don't need zoom 6. I only need what?
Zoom 24.
I only need 0, don't I? So I'm going to show you a good, cool thing. Go to window, window. Okay, in window, I wish I had my other thing up there, but I don't. Okay, in the window it has X minimum. What's my minimum X I need to see?
That's zero.
Zero.
So I just hit 0.
Nice.
Okay, and my max X I need to see probably more than 10 years, right? How about 20? 24? Okay, 24. Okay, scale is 1. What's my minimum Y I need to see?
Minimum Y,
0.
24.
I don't need to see anything below 0, do I?
0.
Okay, because that's the horizontal asymptote. So
24.
24 for your max.
the max is 24. How about we go 26 just so we, because if you go 24, it's like at the top, it like cuts it off.
No, the max.
The max Y is 26. Okay, because listen, if we go to 24, the screen is going to be like at 24 and you'll miss it. Does that make sense? So on your window, it should read 0, 24, 1, 0, 26. Don't mess with anything else. Reading down, it should say 0, 24, 1, 0, 26. Got it?
Yes.
Now hit graph. One time,
Oh,
Natalie.
17 times, Natalie.
Okay.
Wait, but I messed up. I missed the first.
You have the nicest calculator in here, and you can't do
This
the
is
first
so
part of it.
hard.
What did you mess up on?
I just didn't put the thing
Oh,
in.
we'll
I
put
was
it in.
confused.
Okay, you're putting this right here.
The original one?
Yes.
Okay, well last
Okay.
time I put that in, it was wrong.
So now, if I want to know when this is worth $5,000, I can't put 5,000 in it at work. So I can hit trace, and if I hit trace and I hit my left or right arrow, it will give me my Y amounts would be my $5,000, right? So I could do that,
6.8. No.
and it
Well, that's 5,100.
yeah, and that kind of jumps, right? Like I got 5.1 to 4.9, and yours would jump differently,
Yeah,
right?
kind
So that change on the window, you could make your change smaller, and it would make smaller jumps. The other thing you could do is you could go to calculate, remember that second trace, and anything you want your calculator to do for you, like exact, is right there. Okay, so you see above the trace button? So I have to hit second and trace, and there's values, zeros, minimums, intersects, the integral, the derivative, obviously 6 and 7 you aren't going to use till calculus. And we don't need zeros, minimums, intersects, all that. We need values, don't we?
Yeah.
So we're going to hit 1. But it says X values.
You need Y
So
values.
I need Y values. So am I still just going to be plugging and guessing?
Yeah.
Yeah.
So 7.
Okay, so if I put in 7, I get 9.033. Okay?
24.
I got
What the?
I got 5.
5.033.
I got 5.1.
Would be, yeah, 5 because we're in thousands of
Why'd you
dollars.
say
Yeah,
29?
you said something weird.
I said 5.033.
You said
That's
9
not what you
square
said the
is a
first time.
Well, whatever. It says 5.033.
Okay.
Okay, so that's kind of okay, right? But I had to do lots of guessing and checking.
No.
Okay, another way we can do this is we can go to your table set, second window. Learning lots of things about your calculator. Okay, so your input should be on auto. Is it already on auto?
Yeah.
Okay, mine was not because I use this I put in an equation for your test, and then I go in and put how many you got missed, and then it spits out the score. So I make equations, and it just does it easier that way. So I'm gonna put my table start at 0, because I don't need, those are X's, right? Do I need any other zeros negative? Do I need negative zeros? No. And I want T, the change, because delta is a triangle, that means change, okay? So do we want our change to change by each year? Or do you want to change it by half a year? How do you want to change it?
Each year.
Each year. So I'm going to make that sure that delta just says 1. You have
What
that delta table, triangle table. That means delta.
Because you can't lose.
Then go back to the graph?
Yeah, delta table. Delta table.
Can you still
Pretty
lose?
sure that's one.
Can you still lose value on half a year of owning your car? Does that have to be a full year until it loses?
No,
its
it's
value?
any day, I think. I don't know.
Every day you lose 0.2%.
And values of cars are more complicated than an equation because it's the demand. You could have a 30-year-old car that's worth more than a 10-year-old car, just depending on what it is and all that.
Wait, if you
Depends on
want,
what
can you just go to the table and then look? for
Yeah, that's
which
what
one?
we're setting up.
Oh.
Okay, now, do you guys see table above graph?
Yeah.
Okay, so hit second table now that we've done that. Okay, now can you see what the car is worth each year?
Oh, yeah.
So at 10 years, what's the car worth?
$27. 10 years.
$2,558,
Well, above that.
77.
or 2,577. I don't even know what I'm doing in my brain. Okay, so now is it clear to see where it's worth $5,000?
Yeah.
Yes.
I've got my.
So there's many things I can do with this, okay, that can help me evaluate functions. And they're very valuable with application problems.
I have messed mine up.
Nope,
royally.
45
Why?
years and we got
Because at
$1.
-7, I've got 4.7.
Yeah, I just did the
which is
same
at
thing.
5,000.
I don't know.
What?
I don't know.
Went all the way down to the bottom where it was.
Okay. So, are there things on here that I can do to check my work
There's
and
a
stuff
lot
like
of
that?
things
And
you
we
can
will
do.
continue from time to time. Once in a while, we will have just a complete graphing calculator test. Like, you have to be able to do this on a graphing calculator. So, I have
Where's that?
checked these all out to you. Please bring them every day. So when I say, hey, take it out, we can do that. Austin.
Why is it
What do
in
you
my
want?
bag?
Evan, you never took yours out?
I took it out.
I thought it was in my bag.
Crazy ass.
Okay.
Alright, that's it.
And then that's
And
just
the
our
class
review.
info.
That was like perfect timing.